All right, this is the part I've been looking forward to. Today we're going to be setting up our two contenders. We've got Stoat and we've got Rocket.Chat, essentially David and Goliath. Stoat is Discord-like, minimal footprint, almost zero friction deployment. And then there's Rocket.Chat, enterprise grade, feature rich, but it does need extra resources and the setting up of an additional MongoDB instance. Now, although we are going to be putting these through their paces for the next month or so, the real test does start today. Let's see how smooth or not these deployments are. Okay, so on the screen, we have, on the left-hand side, Proxmox virtual environment, and on the right-hand side, we have multi-remote next gen. These are the tools we'll be using today. So let's look at Proxmox first, and I'll show you the foundations for what we'll be doing. These are the two Ubuntu server virtual machines that have already been deployed. Yep, already set them up. Figured you're not really here to watch me deploy a couple of Ubuntu VMs as well as Docker and the two platforms. So these have already been prepared. Here's two I prepared earlier. So number 171 and 172, we can see Ubuntu server Stoat test and Ubuntu server Rock test. Very original naming, but I like it because it's easy for me to understand. Now, just going to consult my notes. These are the allocated resources for each of these servers, which you can probably see on this UI here as well. But Stoat server has been allocated 4 CPU sockets, 6 gigabytes of memory, and 70 gigabytes of storage. Rocket.Chat has been allocated 6 CPU sockets, 8 gigabytes of memory, and 90 gigabytes of storage. So in just a raw comparison of like the resources allocated, Stoat's the winner. It uses less CPUs, it uses less memory, and less storage needs to be provisioned for it. So yeah. Now something else I wanted to show you, just about the configuration side, is if we go to hardware, and you can see here that on the memory there is a flag, a balloon flag of 0. Now, both of these applications use WebRTC for the voice communications side of things. And incidentally, Stoat is native, and there's a Jitsi integration for Rocket.Chat. And because they do use WebRTC, that tends to prefer more stable CPU load to be for communication to be smooth. And that's why in this instance, for this test, I want to leave out as many variables as possible. So each of these servers has sort of statically allocated resources. So there's no ballooning here, and there's no ballooning here. Okay, so next bit, we're going to go through the installation of Docker, and then we're going to use Docker to install both Stoat and Rocket.Chat. I'll be using the documentation from Docker for Docker install. I'll be using the GitHub self-hosted documentation for Stoat, and I'll be using Rocket.Chat's documentation for their deployment. All of these links will be in the description below. Let's get into the first deployment, which will be Docker and Stoat on the Stoat VM. The Docker documentation is actually really good. There is a little bit more at the top, but we don't need to uninstall old versions, so we're going to skip past that and just go straight to installation methods. So the first thing we need to do is we need to set up the apt repository. And before we do that, let's remote into the server. All right, so first thing we'll do, that's good practice. Hopefully I remember the password. Yes, awesome. This is good practice. Anytime you're deploying anything new, doesn't have to be a server either, anything using any sort of package manager, just go through the whole update and upgrade process. But there is a caveat on that, actually. Sort of the difference between production and sort of at-home type environments, which is something we'll see mentioned in the Rocket.Chat deployment a bit later. Yeah, obviously at home, it's not so critical if there's for applications to sort of be running and to be available all the time, not in the same sort of way that enterprise type environment is. And so saying that advice for sort of always go through the update upgrade, absolutely can apply to your personal stuff at home, but obviously you'll have a different process. An enterprise environment, you'll be much more staggered, much more sort of methodical about how you deploy upgrades and update. Oftentimes, some companies could be 3 months, 4 months, 5, 6 months even behind on even the operating system updates, just so that they know that what they're adding into the environment, what they're changing is going to be stable, because that's more important than having the latest updates. Obviously, there are some caveats on that. If you've got a 0-day or high-risk vulnerabilities that have been discovered and patched, those updates are very important. There would be some kind of change management process implemented so that could be done methodically, safely, with a rollback plan if there are problems. But anyway, let's get back to this. First thing we'll do, we're literally just going to copy and paste these, because as long as we don't get too excited and double click the paste button, this is much safer than typing out. We're taking out human error by doing this. And don't worry, there's still plenty of opportunity for human error in this, but let's try and reduce it as much as we possibly can. This part, I'm going to copy all of it because it is setting a file up. And the indicator for that is at the end of the first line, EOF, which stands for end of file. It's also got the 2 chevrons there, but we'll paste that, hit return. We can see that that's been set up there. Now, excellent. Let's go back to... Okay, let's clear that again. All right, now we're going to install Docker and Docker Compose. We're going to click yes to confirm that we want to do that. Yeah. All right, let's see if it is running. Excellent. So there we can see it is enabled and it is running. So enabled essentially means that every time this server boots, it will automatically start with the server. So we're going to hit Q there, clear that. Oh, go on, let's do this as well. So we're going to verify the installation is successful. Yeah, that looks good. So as you can see, it pulled it from the library and then it ran it. As you can see, hello from Docker. Stage 2, let's deploy Stoat. The very sort of initial part of the Stoat documentation will go through deploying a VPS on Hostinger. They've obviously got an agreement or affiliation with them. So we're going to go down a little bit past that. Let's take a look at securing your server first. Okay, so again, as you can see, update the system. First thing we're going to do, we're going to configure the firewall using UFW. We'll copy all these firewall rules. Oh, let's just go straight to root and then we'll do that again. This is a great sort of point of learning about firewalls here. You want to by default, you want to deny absolutely everything. And then you want to whitelist the communications that you want into the network. But anyway, good tip there. Default deny and then specify what you want to come through. This is a test environment. I can only access these servers from this environment here, this local network. So I'm not going to worry about setting up an SSH key. If, for example, this was a production environment and I was able to access it from externally, then we would ideally want SSH keys because they are substantially more secure than a password. So we're just going to hit reboot. Okay, that's going to kick us. We'll close that connection. And then we will reopen it. Perfect. So let's clone. The exciting bit. Let's clone Stoat. Now we should have a folder Stoat now. The next command is we're going to change permissions on the bash script. And then we are going to run the config, generate config with your domain. This I'm going to blur out in post-production. The next question we get asked is, would you like to place Stoat behind another verse proxy? We're going to hit yes. Caddy is configured to host. You can see the ports here. If you need a different port, modify the compose override YAML file. Would you like to enable camera and screen sharing? That's a yes. Yes received. It's generated encryption keys, and that all looks good. Look at that. So now we have additional files there. What I'm going to do is I'm going to make a copy of the secrets.env file. As good practice, just in case I make a mistake or something goes wrong, we've at least got, we've got a copy of the last setup of the secrets. Obviously, if we lose the secrets, we lose access, and the whole thing needs to be redeployed again. Okay, so let's see what happens if we run docker compose up, which means we're going to run this in the foreground, so we'll get to see everything that happens. All right. Okay, so this looks like there's an error. Dependency database failed to start. So it's a good idea to run this first because we get to see. Okay, so here's another one. This might be why. Warning. MongoDB 5.0 Plus requires a CPU with AVX support. Most modern CPUs do support AVX instruction sets, but let's MongoDB warning AVX Proxmox. Okay, so what that's saying is the warning requires in Proxmox occur because the default virtual CPU model, such as KVM64, QEMU64, or x86-64v2-AES, intentionally hide the AVX instruction set to ensure compatibility across different physical hosts. As it says here, change the type from the default to host, which will be essentially passing through what the host hardware is. So let's go back to here. Let's hit shutdown. Network connections closed. That's to stop. Okay, let's go into the settings. So as you can see, you can specify exactly what the architecture of your CPU is. Host. No other changes need to be made. We're going to click OK. All right, let's start that server up again. And we will reconnect. Oh, doofus. All right. Now that looks a lot better. Awesome. Okay, so the database dependency issue has been sorted. That's something that anytime you get an error message, anytime something goes wrong, error messages are literally the goldmine. If you already know what it's referring to, fantastic. If you don't, you can then copy and paste that into a search, quickly get some answers on what it is you're looking to solve. So let's hit D to detach that. And now, pretty sure that this was set up on port 8880. So let's look that up. 192.168.3.171. Oh, 71.8880. And there we go. So we can log in or we can sign up. The next step is to be able to make this available externally. And to do that, I'm going to set up port forwarding on my router. And this part here, where it's showing you, note, if you are using another cloud provider or you're doing this on a physical machine, which is what we are, you will need to forward the ports 80, 443, 7881, and then 50,000 to 50,100 in UDP. And then that essentially is Stoat setup. Now it's time to do the Rocket.Chat install. Some notes I have on Rocket.Chat are it's recommended to deploy using Docker. It does come with a stack of monitoring tools, Prometheus, Loki, and Grafana, which we will be leveraging, and I will show you those as part of the one of the later videos where we go through the testing results to see which one we're going to use for our Discord server. It also has a MongoDB database that is set up as part of the Docker installation. It does also have another cool feature, which is it's got its integrated testing project. So a bit like a plugin add-on type thing, and it helps to synthetically test the server itself as if simulating user activity, etc. So that'll be a nice way to do some testing at least before both of these servers are opened up to external users to register and log in. On the main screen up here, you've got Rocket.Chat Deployment documentation. And as you can see here in this guide, we're basically going to learn how to deploy Rocket.Chat using Docker Compose, update Rocket.Chat to a new version, update MongoDB to a compatible version in Docker, backup and restore the Mongo database, and configure Rocket.Chat using environment variables in Docker. Now, what we will have at the end of this is a running instance of Rocket.Chat, a reverse proxy. Now, this is something that I wasn't initially planning on, but as I've looked into the configuration, I'm going to expand this out. And so this is going to end up being 4 videos as opposed to the original plan of 3. And the reason for that is the next video I'm going to do will be simply around setting up a dedicated reverse proxy server. I already have some resources that have external connections. I want these 2 servers to have external connections. I also have some other resources which we'll be deploying over the next couple of months that I will also want to have external connections. And so it's essentially meaning I'm going to be using subdomains, multiple subdomains coming through the one external IP. And so what I've discovered in looking into this is not all of the resources suit port forwarding on the router for security reasons. So some of them I'm going to pass through to an internal reverse proxy, which then handles which of the resources that goes to. Game servers I'm going to continue running through port forwarding because they need the speed. They're going to it's all TCP and UDP traffic communication, so latency is super important. There's a kind of segregation depending on the type of resource. It's going to be really cool, but it has meant that this project has expanded a bit from the initial plan, right? We're not going to go through the reverse proxy on this one. That'll be a dedicated video next, which again, just to repeat, dedicated server specifically for that, and then separated into 2 distinct sets of traffic. All right, so let's start off. First step is to install Docker, Docker Compose, and Git. So let's first of all install Docker. Then we're going to add our user to the Docker group. And we'll reboot for these to take effect. Next step, I'm going to clone the official Rocket.Chat repository. Okay, excellent, look at that. And we are now in there. So the repository includes a compose.yaml, which is here, and a .env.example file. That's why we can't see it there. So there's the .env.example file. Because it's a dot file, it means it's hidden file. So we're going to copy that to .env. I thought that was wrong. Okay, so I'm going to work through configuration. Now this one says release 8.0.1. As you can see here, it says change to true after you've set your domain and valid. Let's encrypt email. So we'll come back to that. I was looking down there, wrong place. I need to look up here. So that we'll come back to that. So let's configure monitoring. Prometheus collects metrics, Loki aggregates logs, and Grafana provides a cool dashboard. So I'm going to deploy Grafana using a path rather than a subdomain. It's a local deployment, and it's also a single domain setup, so it kind of suits that. So the Grafana domain, can leave that blank. And the path, set this to your desired path, ensuring there is no trailing slash, e.g. /Grafana. I'm pretty happy with that. Grafana admin password. I think I'll leave that as it is. Okay, configure the domain and reverse proxy. Now, because this is going to be getting set up in the next video, I'm not going to make any changes as per this section because, yeah, it'll be a dedicated reverse proxy server. Optional configurations. If you have an external MongoDB connection, you could set this up. And registration token. If you received a registration token from their sales team, so this is if you're using an enterprise version of this, we don't have that, so we'll leave that blank. So let's Control X. Basically didn't make any changes, so that just gets saved. Download all of these container images that we need. As you can see, MongoDB, Prometheus, Grafana, and the Rocket.Chat instance, and traffic at the end. Nice. Now, depending on how I set this up, I need to read a bit up on this before I go through it. But if the internal dedicated reverse proxy server is enough, then I don't need one on this instance. I might not end up using the traffic container on this instance. I might just use the reverse proxy that I'm going to deploy into the environment to manage all of these resources. Now, part of this instruction here says up-d. So once these are all pulled, it should load them all, and then we have this command here to make sure we can see them running. Here we go, started. Let's see what. Nice. So up. That's exactly what we want to see. So now let's see if we can see if this actually worked. So this says localhost at port 3000. The IP of this server is close to outstanding. Okay, so there we go. That's Rocket.Chat installed locally and accessible from within the network. In this episode, we've just installed and stood up a Stoat instance and a Rocket.Chat instance. Currently, they're unable to communicate externally, and so to do that, I'm going to need to open up some ports on my gateway router and sort of researching the reverse proxy side of things, and also researching other projects that I will be implementing over the next 2 to 3 months. This project's essentially expanded beyond what I was initially thinking it would. And so this particular series was going to have 3 videos. Now there's going to be a fourth video, but it's going to be the next video, which will be the third video. And it's essentially setting up dedicated reverse proxy server. I've already got a game server that has multiple games with traffic being put forwarded through my gateway router. I want to set up a second using a different framework. So currently I'm using AMP by Kubecoders. I want to set up a pterodactyl instance on a separate server and run some other games on that. I'm going to be running these 2 chat servers. I have an N8N instance that I want to access externally. I actually want to have another N8N again, so that's another service. I'm also going to be deploying a local large language model, which I want to be able to communicate externally. And I also have a sort of a virtual cybersecurity environment for some cool projects that are coming over the next few months. But essentially, there's a lot of different resources there and different types of resources. And so what I've discovered was, in terms of the network traffic, the game servers really do need to have the lowest latency possible. And it's all TCP UDP traffic. So I'm not going to pass that through the reverse proxy. I'm going to have them coming directly in on the gateway router, port forwarding straight to those hosts. The rest of the resources, I want to host behind a reverse proxy, which can help protect them and also delineate the traffic depending on what the resource is. And so the route I'm going to be taking will be to use subdomains on the URL, which is completely new to me, never done this before. And so it's been a bit of a rabbit hole researching this. And so each of the different resources will have a different subdomain. Now, with my dynamic DNS provider, I've paid a small fee to get an extra 4 domains, and I'm going to use that to still keep the main domain name, and then it's going to be sort of n8n dot llm dot. These are just examples right now, but over the next few months we'll be setting these up. And so it's really exciting. And so the next step for this will be to build and deploy a reverse proxy server, and that will be the next video in this series instead of looking at the results, because I need to get these two chat servers communicating externally. I wanted to improve the security, and so they're not just going to be on port forwarding. I'll have a dedicated instance for reverse proxy, which will then help with that. And yes, it's gonna be pretty cool. But next episode, can't wait to see you there. And we're going to set up that reverse proxy. See you then.